Okay, what have we seen so far? 3-sat is NP complete. Okay, let's see what we can do from there. Well, one nice fact about this relationship of polynomial time reductions is that it's transitive. What does that mean? If A can be reduced to B and B can be reduced to C, then A can be reduced to C. Just chain these translations together. If you can translate from English to French and then from French to Swahili, you can translate from English to Swahili. Well, this is kind of nice because now that we have a couple of NP-complete problems, we can just translate from them to other new problems, which are then NP-complete. We don't have to go all the way back to the beginning and think about programs that are checking for just anything. So that's kind of nice. So we can prove that a new problem is NP-complete by reducing any other problem that we already know is NP-complete to the new one. Let's do one more thing. It's kind of Boolean, but it's going to really come in handy. It's called NAESAT, which stands for not all equal. You probably already know that computer scientists seem to like these 3-letter acronyms. Go figure. All right, so what is not all equal sat? Well, remember that a 3-sat clause says this or this or this. It wants at least one of these to be true. Not all equal wants at least one to be true and at least one to be false. It's kind of a symmetric problem. It doesn't want them all to be the same, meaning it doesn't want them all to be false or all to be true. So we can still think of this as true and false if we want. It's just a different constraint. It's just a different gadget that you can pick up at the hardware store. We could write it in this way. We could say that x1, x2, and x3 have this not all equal relationship if x1 or x2 or x3 is true and x1 is false or x2 is false or x3 is false. Quiz! Is this a reduction from 3-sat to not all equal sat? Think carefully. No, it's not a reduction from 3-sat to not all equal sat. It's the other way around. What I just showed you was how to express not all equal sat in terms of 3-sat. If we want to prove that not all equal sat is NP complete, we need to express 3-sat in terms of not all equal sat. We need to build 3-sat clauses out of not all equal sat building blocks. Not what I did here, which was build the not all equal sat clause out of a pair of 3-sat building blocks. This can be tricky to keep track of. And even professional computer scientists often confuse when they mean reduce from or reduce to. So we need to keep track of what we need to do. We want to reduce from 3-sat to not all equal sat. But doing this is actually a little bit tricky. 3-sat is asymmetric. It prefers truth to falsehood. It wants at least one of these things to be true. We need to try to build it out of symmetric parts. That's a little strange. It's not clear that we can get off the ground with that. Well, again, you're allowed to add more variables. So let's add a new variable, s. It's going to be a global variable which will be all over the place in the formula. And we're going to use it to break this symmetry. In a sense, s will define which value of our variables means true and which value means false. It may sound like we're playing fast and loose with the logic here, but we're allowed to do this. We can choose what the variables in our new problem mean in terms of the old problem we're trying to translate to it. So think about this clause. x1, x2, x3, and s can't all be the same. Well, whatever s is, let's say s is what we call false, then at least one of x1, x2, and x3 must be true. If s is true, then at least one of x1, x2, x3 must be false, but heck, then I'll just flip true and false, because I can do that. I'm choosing how the translation works. I'm in the driver's seat. So what we've just done is translate 3-sat to not all equal 4-sat, Okay, fine. Each of my clauses has 4 variables in it instead of 3. But I already showed you before how to break up, for instance, 5 sat clauses into 3 sat clauses. And you can do the same thing here just by adding another variable or 2. And then we're done. I'll leave that last step to you as an exercise.